Now next problem, if tan x is equal to 8 upon 15 and sec y is equal to 5 upon 4, evaluate cosec x and sec x plus tan y. Now we take the first part, we want to find cosec x. Now we have the formula 1 plus cot square x is equal to cosec square x, but we are given tan x as 8 upon 15 and we know cot is the reciprocal of tan, so we get cot x as 15 upon 8. We substitute in the formula to get 1 plus 15 upon 8 the whole square is equal to cosec square x. Now expand it as 1 plus 225 upon 64 is equal to cosec square x. Take the LCM as 64, we get 64 plus 225 upon 64 is equal to cosec square x. Now 289 upon 64 is the same RHS. Now we have cosec square x in RHS. We take the root on both the sides to get root of 289 upon 64 is equal to cosec x. That is, cosec x is equal to 17 upon 8. We discard the negative value here because cosec cannot be negative. Now the second part here, we want to evaluate sec x plus tan y. To do this, we first need to find the value of sec x and tan y. Let's take for sec x. We have the formula 1 plus tan square x is equal to sec square x. So we substitute tan x as 8 upon 15. Now the square of that would be 64 upon 225. So the equation becomes 1 plus 64 upon 225 is equal to sec square x. Take the LCM to get 225 plus 64 upon 225 is equal to sec square x. That is 289 upon 225 is equal to sec square x. Take the square roots on both the sides, we get sec x is equal to root of 289 upon 225, which is 17 upon 15. Same way here, we just take the positive value because sec cannot be negative. Now we want to find tan y. We use the identity 1 plus tan square y is equal to sec square y because we are given the value of sec y. We get 1 plus tan square y is equal to 5 upon 4 the whole square, which gives us 25 upon 16. Now we simplify this as 1 plus tan square y is equal to 25 upon 16. Transfer 1 to the other side, we have tan square y is equal to 25 upon 16 minus 1. Take the LCM as 16, 25 minus 16 upon 16, which is 9 upon 16. But this is tan square y. So tan y is 3 upon 4. Now we want to find sec x plus tan y, which will be 17 upon 15 plus 3 upon 4. Now we have to take the LCM. 15 and 4 would be 60. So we get 68 plus 45 upon 60, which is 113 upon 60. So we have found the value of sec x plus tan y as 113 upon 60. Now let's look at the next problem. Find the acute angle theta satisfying 5 tan square theta plus 3 is equal to 9 sec theta. Now here we are given this identity and we want to find the angle theta. Now in LHS we have tan theta, whereas in RHS we have sec theta. Now to solve this, we bring tan to sec. That is, we substitute tan square theta as sec square theta minus 1. So we can write this as 5 into sec square theta minus 1 plus 3 equals 9 sec theta. Open the brackets to get 5 sec square theta minus 5 plus 3 equals 9 sec theta. Now take 9 sec theta to the other side. We have 5 sec square theta minus 9 sec theta minus 5 plus 3 gives us minus 2, which is equal to 0. Now we have a quadratic equation. We want to factorize this. So we want two numbers whose product is minus 10 and sum is minus 9. So let the numbers be minus 10 and plus 1. So we write the equation as 5 sec square theta minus 10 sec theta plus sec theta minus 2 equal to 0. Now from the first two terms, 5 sec theta common, we have sec theta minus 2. From the last two terms, plus 1 common, we have sec theta minus 2 equal to 0. We factorize this as 5 sec theta plus 1 into sec theta minus 2 equal to 0. Now their product is 0, so one of them is 0. If we put the first bracket to 0, we get sec theta is equal to minus 1 upon 5. And from the second bracket we get sec theta is equal to 2. But here it is given theta is an acute angle. So if theta is an acute angle, sec theta cannot be negative. So we discard sec theta as minus 1 upon 5. We get sec theta is equal to 2. Now we want to find for what value of theta. So sec theta is 2, but sec 60 is 2. We know that. So theta is equal to 60 degrees. Now to the next problem, which is quite interesting. If tan theta plus sin theta is equal to m and tan theta minus sin theta is equal to n, prove that m square minus n square is equal to 4 root mn. Now here we are given the values of m and n. So we start with LHS and substitute m and n. Now LHS becomes m square minus n square, which is tan theta plus sin theta the whole square minus tan theta minus sin theta the whole square. Now we expand these as tan square theta plus 2 tan theta sin theta plus sin square theta minus in bracket tan square theta minus 2 tan theta sin theta plus sin square theta. Now we look at these two brackets. We have tan square minus tan square, they cancel. We have sin square minus sin square cancels. We are left with 2 tan theta sin theta minus of minus gives us plus 2 sin theta tan theta, which is 4 tan theta sin theta. Now we take the RHS, which is 4 root mn. Now we substitute the values of m and n over here to get 4 into root tan theta plus sin theta into tan theta minus sin theta, which can be simplified as 4 into root tan square theta minus sin square theta. Now we replace tan as sin upon cos. We get 4 root sin square theta upon cos square theta minus sin square theta. Take the LCM in the root. We have 4 into root sin square theta minus sin square theta cos square theta upon cos square theta. Now from the numerator in the root, we remove sin square outside. We have 1 minus cos square theta, which is nothing but sin square theta. We get 4 into root sin square theta upon cos square theta, which is equal to 4 into sin theta upon cos theta. We are removing the root sign. Now sin theta upon cos theta is tan theta and sin theta as it is. So the RHS becomes 4 tan theta sin theta. But LHS was 4 tan theta sin theta, which is the same as RHS. So we have proved LHS equal to RHS. Now let's look at this topic from the board point of view. This topic carries 3 to 4 marks in the ICSE board examination. There is one question based on this topic either in section A or section B, but generally it is in section B. Now, where can you lose marks in this topic? Whenever you are proving an identity, always mention the fundamental identity which you are using to solve it. Also remember, whenever you are proving, you have LHS and RHS. We normally start with LHS and arrive at RHS. Or you could take LHS separately and RHS separately and prove them to be equal. But do not assume that LHS and RHS are equal and solve them at the same time. In doing so, it is possible that no marks may be awarded. Now let's look at some board problems. We start with the March 2005 board question, which is prove that 1 plus tan A the whole square plus 1 minus tan A the whole square is equal to 2 sec square A. We start with the LHS. Now in LHS we have tan A and in RHS we have sec A. So it's quite obvious we want to replace tan in terms of sec. But before doing that, let's expand the LHS as 1 plus tan square A plus 2 tan A plus 1 plus tan square A minus 2 tan A. Now 1 plus 1 gives us 2, tan square A plus tan square A, 2 tan square A, and minus 2 tan A and plus 2 tan A cancels. So we are left with 2 plus 2 tan square A. Remove 2 outside. We have 2 into 1 plus tan square A. Now what is 1 plus tan square A? Sec square A. We get 2 sec square A, which is nothing but our RHS. So we have proved LHS equal to RHS. next problem, which is the March 2006 board question. Prove that sin theta into tan theta upon 1 minus cos theta equals 1 plus sec theta. Now we start with LHS. We write it as sin theta into tan theta into 1 upon 1 minus cos theta. In LHS, we have sin and cos. So we write tan theta as sin theta upon cos theta. We get the LHS as sin theta into sin theta upon cos theta into 1 upon 1 minus cos theta. Now the numerator becomes sin square theta, denominator as it is. Now in RHS, we want sec theta. So we write LHS in terms of cos theta because we know that from cos we can get sec quite easily. So we write sin square theta as 1 minus cos square theta and the remaining terms as it is. Now 1 minus cos square theta can be factorized as 1 minus cos theta into 1 plus cos theta. Now we have 1 minus cos theta in the numerator and denominator. We can cancel. We are left with 1 plus cos theta upon cos theta. Now we want 1 plus sec theta in the RHS. So we separate the denominator, that is we write 1 upon cos theta plus cos theta upon cos theta. Now 1 upon cos theta is sec theta and cos theta upon cos theta gives us 1. So we've got sec theta plus 1. We rearrange this and have 1 plus sec theta, which is nothing but our RHS. So we have proved LHS and RHS equal. Now let's take the March 2007 board question, which is prove the identity sec a minus 1 upon sec a plus 1 equals 1 minus cos a upon 1 plus cos a. Now this sum is quite simple. We are given sec in the left side and we want cos in the right side. So we will substitute sec in the left as 1 upon cos. So we get the left hand side as 1 upon cos a minus 1 upon cos a plus 1. Now take the LCM in the numerator and denominator as cos a. We get 1 minus cos a upon cos a, the whole thing upon 1 plus cos a upon cos a. Now cos a cancels. We have 1 minus cos a upon 1 plus cos a, which is RHS. So we have proved LHS and RHS equal. Now we have the March 2008 board problem on our screen, which is prove the identity sin a upon 1 plus cos a is equal to cosec a minus cot a. We obviously start with the LHS, which is sin a upon 1 plus cos a. Here in the denominator you see we have 1 plus cos a. So what should you do? We rationalize the denominator, that is multiply by 1 minus cos a. We get sin a into 1 minus cos a upon 1 plus cos A into 1 minus cos A. Now in the numerator, we keep it as it is. The denominator, 1 minus cos A into 1 plus cos A gives us 1 minus cos square A, which is nothing but sin square A. Because of the identity, sin square A plus cos square A equal to 1. So we have the LHS as sin A into 1 minus cos A upon sin square A. Sin square A cancels. We are left with 1 minus cos A upon sin A. Now, we want cosec A and cot A in the RHS. So, we separate the denominator, that is, we write 1 upon sin A minus cos A upon sin A. Now, what is 1 upon sin A? It's cosec A, and cos A upon sin A gives us cot A. So, we have got cosec A minus cot A, which is nothing but our RHS. So, we have proved LHS and RHS equal. Now let's look at the brain map of this topic. We have now seen what is trigonometry, which are the fundamental identities, the proofs of the fundamental identities, how to solve a trigonometric identity. Let's revise them at a glance. What is trigonometry? Trigonon means triangle, metron means measure. So trigonometry is the measure of the sides and angles of a right-angled triangle. Now, which are the fundamental identities? They are sin square A plus cos square A is equal to 1, 1 plus tan square A is equal to sec square A, 1 plus cot square A is equal to cosec square A. We've also seen the proofs of the fundamental identities. We took a right-angled triangle and used Pythagoras theorem and got the different identities. Now, we've also seen how to solve a trigonometric identity. These are equations with left-hand side and right-hand side. We start with LHS and arrive at RHS. I hope you have understood this topic well, but this topic needs a lot of practice because every sum can have a different approach. So, if you study well, you can score full marks in this topic in your forthcoming boards.